Okay, this is going over the Chapter 3 assessment for IB Math Studies. For those of you who were unable to come in and get assistance but still want to take a retest. I know it might be a little bit blurry on the video screen, and I'm having trouble getting it worked out, so just bear with me. Okay, the paper 1 question. The diagram shows a triangle ABC in which AC is 17, so from here to here is 17 centimeters. M is the midpoint of AC. Well, that means that this is 8.5 centimeters on this side and 8.5 centimeters on this side. The triangle ABM is equilateral. An equilateral triangle means that all 3 sides are the same. Another thing that we know about an equilateral triangle is that all 3 angles are also the same. So all of that information is strictly from the problem. The first question is write down the length of BM in centimeters. Well, since we knew that was equilateral, then BM is 8.5 centimeters. The size of angle BMC. So BMC is right here. Now together those 2 angles make up 180 degrees, so that leaves us 120 degrees left for that side. The next part asks for the angle of MCB, so this angle right here. Now, since these 2 sides are the same, that means that these 2 angles have to be the same as well. If we have 120 degrees taken up here, then there's 60 to go between that angle and that angle. So this one's got to be 30 degrees and 30 degrees. The next question is to calculate the length of BC. So this is the only one that says calculate. So they are expecting you to do some mathematics. BC, that's this side right over here. This is our X. Well, one thing you can do is, since this triangle right here is not a right triangle, one thing you could do is do law of sines, or sine rule. Sine rule says if I take a side over the sine of the angle across from it, that is equal to the side length over the sine of the angle across from that side. So I could do X over sine of 120 equals 8.5 over the sine of 30. That would be one approach to this problem. It's probably the easiest and the most straightforward as well. Remember, always showing what you plugged in to each of the formulas. Making sure your mode is in degrees as well. 8.5 times the sine of 120, and then you would end up dividing by the sine of 30. And I got, in the calculator, I got 14.722, so that would be 14.7 centimeters. Number 2. This one we were looking for possible conditions with the pairs of M and C. Looking at the equation y equals mx, and they do call it plus c in Europe. Now we changed this one to greater than in class. M is the slope, c is your y-intercept. So the first one, slope is greater than 0, so positive slope, and the y-intercept is positive as well. Well, this one's going downhill as well as this one, so those both have a negative slope. This one has a positive slope, but its y-intercept is below the x-axis, so that is a negative y-intercept. So we're looking for one that's going up. Here's 2 more going up with a y-intercept that's positive. It's got to be that option, which is L5. The next one, slope is negative and y-intercept is positive. So let's look for those negative slopes. Negative slope, but the y-intercept is negative. Negative slope, but the y-intercept is 0. Negative slope and a y-intercept that's positive. That's what we were looking for. That's L4. Negative slope, but the y-intercept is negative. We already saw that. I believe it was right there. This one, last one, has a positive slope and a y-intercept that is negative. Positive slope, y-intercept is negative. That is all they actually wanted you to do on that problem. Problem 3. We're given a graph, and the points A, which I know it's hard to see on this one, it's 2, 5, and this point is 8, 2. They ask us to write down the y-intercept of the line AB. If it says to write down, then we shouldn't have to do any calculations. Here's the y-axis. So this line is going through this point, and that is 6, or actually the point 0, 6. Calculate the gradient of the line AB. Well, gradient is the same thing as slope. They're talking about the difference in the y's over the difference in the x's. And my y values, here was a 2, 5, so that's 2 minus 5. And the x values are an 8 and a 2. So down here it would be 8 minus 2. 2 minus 5 is a negative 3. 8 minus 2 is a 6. So I end up with negative 1/2. Now, the next portion says that the acute angle between line AB and the x-axis is theta. Theta is kind of a variable used for unknown angles. Show theta on the diagram. Well, that would be between AB and the x-axis. That would be right here. Calculate the size of theta. Well, I know I'm on a grid, and that's a right angle. So maybe I could use a little bit of just the simplistic trig. That's so, ka, toa. So let's see if we know anything. Well, this side here was 6, because it went all the way up to 6. And this side over here goes to 12. So compared to that angle, this would be my opposite, and this side would be the adjacent. So opposite, that would be tangent. Tangent is the opposite over the adjacent. So the tangent of theta is opposite over adjacent, and our opposite side was 6, adjacent was 12. 6 over 12. Now remember, to actually find the angle in the calculator, we're going to take the inverse tangent. So, second tangent, 6 over 12. And it gives me 26.56, which would be 26.6 degrees. Number 4. We have the vertices of a triangle ABC. We got A is 4, 3. Let me write this a little bit better. I know it's fuzzy today. B is 7, negative 3. And C, I don't know why I cannot get this to focus better today. C is the point 0.5, comma P. And there's a lot of ways to do this problem, so we'll just go through one method. Now, finding the gradient, there's only one way. Gradient is slope, y2 minus y1 over x2 minus x1. We've got negative 3 minus 3, because it's between A and B, and then 7 minus 4. Negative 6, 7 minus 4 is a 3, so I end up with a negative 2. Now they tell us that AC is actually perpendicular to that line. So we're going to write down the gradient of the line AC. Well, perpendicular means it's going in the opposite direction, and it's actually totally opposite, negative and reciprocal. So this is really negative 2 over 1. So if we take the opposite sign and flip it, that would be 1/2. The next part asks us to find the value of P. Well, P was part of C. So let's think about this. AC is the one that has the slope of this. A is 4/3, and C was 0.5 comma P. The slope between those 2 points is 1/2. So one way to do this is to actually use the slope formula. The slope be the difference in the y's over the difference of your x's. And we could just cross multiply. 1 times 0.5 minus 4, and I'm going to go ahead and find out what 0.5 minus 4 is. That's negative 3.5. When I cross multiply this way, 2 times P minus 3, that would give me 2 times P minus 2 times 3, which is 6. So now I'm going to take that negative 3.5 and I'm going to add 6 to it. And I get 2.5 equals 2P. So divide by 2, and I get that P is 1.25. Number 5. We have A is 2, 1, B is 4, 5. Find the gradient of the line AB. Gradient means the slope of the line. So 5 minus 1 over 4 minus 2. I get 4 over 2, which is 2. It also wants us to write down the coordinates of M, the midpoint between those 2 points. So one way to think about midpoint is the halfway point. It's the average of your x's and the average of your y's. Well, that gives me a 3 and a 3. The last part is we want to find the equation of the line perpendicular to AB that goes through point M. Well, if it's perpendicular to AB, and AB has a slope of 2, then our slope would be negative 1/2. Y equals mx plus c. We know the slope, and we know a point on the line. That point can go in for x and y. So 3 equals negative 1.5 plus c. Add to the other side, that gives me 4.5 equals c. So the equation would be y equals negative 1/2 x plus 4.5. And that's all they actually expected you to do. Now the next part. I'm going to have to refer back and forth to the paper because this is a paper 2 question. We are asked to do paper 2 questions on separate paper. I'm just going to use notebook paper to save money. And we're going to talk through what we have. But I'm going to actually redraw my picture on my paper so we have this to refer to. Okay, the picture has A, B, and then this is not to scale, but it's going to give us something to draw on and think about. This is 75 degrees here, 55 degrees here. That was an N. So this is how the problem came. And the first question is to write down the size of angle ABC. Well, if we look at the angles, these 2 angles we know, this one we don't out of the big triangles. They all add up to 180. So for the first part, and this is 6A, I would take 180 subtract 75, which is one of the angles, and then subtract 55, which is the other one. So if I took my calculator and did 180 minus 75 minus 55, I get 50 degrees. So angle ABC is 50 degrees. Part B asks us to calculate AC. So I'm going to look back at my picture. Now when you're on a paper 2 type question, they tend to lead onto each other. So like you need part A to do part B. Well, angle A, we know little a across from it. We just found angle B, so I know I'm going to need to use that information. And we're trying to find that side. Well, in the big picture, that would be little b, because it's across from big B. I'm thinking the sine rule would be perfect. Little a over sine of A equals little b over sine of B. So 25 over the sine of 55 equals little b over the sine of 50. They don't care about the nitpicky arithmetic in between, but they do want to see which formula you plugged into and what answer you got. Now when I did the calculation, I did 25 times the sine of 50 divided by the sine of 55, and I got 23.37, but 3 significant figures would give me 23.4. Calculate the area of the field. Now the formula for area is 1/2 A times B times sine of C. It's a side times a side times the sine of the angle between. Well, we actually happen to know A, B, and angle C. So we will literally go from that times 25 times 23.4 times sine of 75. And I got 2825.333. Remember, 3 significant figures, so I'd get a 283. Oh, and I forgot my units. I was fixing to get marked off for that. Our units were meters. So this should have been meters, and this should have been meters squared. Don't forget your units. Now the next part says that N is the point on AB such that this is perpendicular, and it did have that marked, and M is the midpoint of CN. Calculate the length of N to M. Well, this is nice because this is a right triangle. I could find this whole length and then just take half of it. Well, let's see. This whole thing is what we want to know, CN, and it is opposite from 50 degrees, and 25 meters is the hypotenuse, so opposite and a hypotenuse, that sounds like sine. The sine of 50 would have been the opposite, which would have been that length CN, over the hypotenuse of 25. So CN would be 25 times sine of 50, which is 19.15. And I am writing that one out because that's not my final answer. And I'm dividing that by 2, and I got 9.575, so that's going to round to 9.58 for MN. So I go ahead and go back and mark that in my picture. And so this side would also be 9.58. Now, it says that a goat is attached to one end of a rope of length 7. So we got the rope is tied at M. There is a midpoint of CB, which is the point P. Midpoint. So that would be 12.5 here. We want to know if the goat's going to reach it. So we have another right triangle here. We know that side. We know that side. Could we find out how long this side is to get to the goat? What's a right triangle? Guys, that's Pythagorean Theorem. Hypotenuse is 12.5, and that side is 9.58. So, x squared plus 9.58 squared, it equals 12.5 squared. Whoops, not degrees squared. So I'm going to do 12.5 squared minus 9.58 squared. Then I take the square root of that, and that will give me how long it is from point M to point P. It is 8.03 meters. Will the goat reach it? The goat will not reach point P because the 7-meter rope is shorter than the distance to P, which is 8 meters. You want to give a good reason when they ask for you to justify your answer. There is no excuse on skimping out when you get to that. Okay, last question. This one we have a graph that we're going to be referring back to. Points A, which is negative 4, 1. B is 0, 9, and they actually give us the points. C is 4, 2. Find the gradient of AB is our first question. So we have the points. I think y'all got the idea of how you would write out everything, but I'm going to go ahead and do it again. Gradient of AB. So on part A, this is 7A. Gradient is y2 minus y1 over x2 minus x1. 9 minus 1 over 0 minus a negative 4. So 9 minus 1 gives us 8. And then we end up with a positive 4 on the bottom. So our slope is 2. L1 passes through C, so here's L1, and is parallel to AB. So this is going to have the same slope, which you could have also counted here as up 2 over 1. So this one is, I got the same slope. Going backwards, it's down 2, back 1, down 2, back 1, and so forth. They want to know when it's going to, what its y-intercept is going to be. Well, I could just keep going with my line. My y-intercept is right there at negative 6. So that's why it said to write down the y-intercept, because there was no mathematics involved at all. L2 passes through A, and it says it is perpendicular to AB. Well, they're telling us that, but they already drew the line in so we can see the slope. If we look at L2, it's going down 1 over 2, down 1 over 2, and so forth. Down 1 over 2, down 1 over 2, and so forth. And it would keep going. So I'm going to connect my dots. They ask us to write an equation of L2. Well, for L2, I have the slope is negative 1/2 because I just looked at it on the graph. The y-intercept, or C in IB talk, is going to be negative 1. Write down the equation. So they're not really asking you to do any calculations, but they are asking you to write it in a different form. They want it in AX plus BY plus D equals 0, and they want A, B, and D to all be integers, so no fractions. So to get rid of the fractions, I can multiply both sides of my equation by a 2. When I multiply both sides by a 2, this side becomes 2y, negative x, and a minus 2. Now I'm going to put everything on the other side. So I'm going to add x, so I get a positive x. The 2y is already there. I'm going to add the 2 to each side of the equation and set that equal to 0. The next part. Write down, so no work needed to show, the coordinates of the point D that intersects L1 and L2. So here was L2, here was L1. They're meeting at that point, and that point is 2, negative 2. So D is 2, negative 2, and that's point D. No math. Says there's a point R on L1 that'll end up making AB RD a rectangle. So we've got to continue this line out. And if it's a rectangle, these are going to be parallel. This one had a slope of down 1 over 2. So I'm going to start at B and go down 1 over 2, down 1 over 2, until I reach the other side. And we needed to name that point R. It says to write down the coordinates of that point. Well, that point is 6 and 6. So E, the point R, is 6, 6. On F, we are given that the distance between A and D is square root of 45. So let's see where that is. A and D, where was D? Oh, this was D, is the square root of 45. Find the distance between D and R. Well, there are a couple of ways to do it. You can use the distance formula, y2 minus y1, and this is the distance formula. And it may be in a different order in some of the books. But really what you're doing is you're finding, you're using the Pythagorean Theorem is what you're really doing. So if I'm using this formula, I'm going to show you another way as well. 6 minus a negative 2 is going to be 6 plus 2. And then 6 minus 2, so that's going to give me an 8 squared plus 4 squared. I end up with the square root of 80 which I could find if I needed to. Or you can leave it like the square root of 80. It's approximately 8.94. What I also wanted to show you is another way to do that. If you're looking at the graph, we're trying to find that distance. Well, I could come off here to the side and make a little right triangle. This distance is a 4. 1, 2, 3, 4, 5, 6, 7, 8. This distance is an 8. 4 squared plus 8 squared would equal that squared. So 4 squared plus 8 squared would equal dr squared. Dr would equal the square root of whatever I got there. I want to show you that it's the same thing. Different order, but same thing. Now the last part said find the area of triangle BDR. So let's look at BDR. BDR. Remember, this is a rectangle, so this is a right triangle. This would be the square root of 45 because this one was the square root of 45. This is the square root of 80 because we just found it. In a right triangle, you can turn it any way you want. Base, height. 1/2 base times height is how you find a triangle. So that would be 1/2 the square root of 80 times the square root of 45. Now, if you are planning to take the retest, I'm going to give you a big hint that you will definitely need to know how to find the area of any triangle, and you're definitely going to need to use cosine rule. I forgot to put cosine rule on this one, so it is present on the retest.